Hi friends! Today we'll be starting a new topic. It is multiplication of expressions. So let's start. If 3 times 4 is written, what does it mean? It means 3 times 4. That is 3 plus 3 plus 3 plus 3. Or 4 times 3 is 4 plus 4 plus 4. Similarly, if we are writing 3x or 3 times x, what does this mean? It means x plus x plus x. Or what if we write 5x? That means 5 times x. This is x plus x plus x plus x plus x. So we added x 5 times. Now, what if we have x to the power of 3? This is x times x times x. X is multiplied 3 times. Now, x to the power of 4. This is x multiplied with itself 4 times. So you need to remember if it is written as 3x, which means 3 times x, that is adding x 3 times to itself, or if we have x to the power of 3, which is where we multiply x with itself 3 times. Now here we have the expression 3xy. This is 3 times x times y. Now when you do not have any sign between the constant or variable and variable, it means multiplication. Now what about 4x squared? This means 4 times x squared, or 4 times x, because x is squared. Now what about 5x to the power of 3y? This is 5 times x times x times x times y. So this is x to the power of 3 times y times 5. Now here we have two expressions, and we have to multiply them. It is 4x times 3x. Now how do we do this? You will be multiplying the coefficient of the first term with the second term, and the variable factor of the first with the second. So multiplying the coefficients, we get 4 times 3 is 12. X times x is x to the power of 2. Now when you have multiplication sign in between the coefficient and the variable, you can omit that sign. And 12 times x squared is the same as 12x squared. Let's try another example. 3xy times 5x squared. How do we solve this? We first multiply the coefficients with each other, and then we multiply the variables. Coefficients are 3 and 5, which is 15 when multiplied. Then variables are x times x squared becomes x cubed. Then finally we have a single y. This just remains as is. So our final answer will become 15 times x cubed times xy. Now once again, there are no signs where the multiplication signs are. So this can become 15x cubed y. Now let's take another example. 3 times 4x. Now here we have a constant and a monomial. So how do we do this? We multiply the coefficients with each other. And in this case, it will be 3 times 4 equals 12. Then finally, we have to multiply the variables, which is just x. So the solution will be 12 times x. This becomes 12x. Next question, negative 5x times 6y. Now we multiply the coefficients, negative 5 and 6. Then we multiply the variables, x times y. Now negative 5 times 6 is the coefficient, x times y are the variables. Now negative 5 times 6 becomes negative 30, and x times y becomes xy. The answer is negative 30xy. Next question. Negative 5x times 12 y squared. So we multiply coefficients, negative 5 times 12. Then we multiply variables, x times y squared. So negative 5 times 12 becomes negative 60. X times y squared is xy squared. So this becomes negative 60xy squared. Next question. 6x cubed times negative 5y. Multiply the coefficients, and then we multiply the variables. So 6 times negative 5 becomes negative 30. X cubed times y becomes x cubed y. Now we multiply these two together. So we get negative 30 times x cubed y. X times y becomes xy. 3x times 4y. Now let's solve this. We have 3 times 4 equals 12. Then x times y, which is xy. Answer is 12xy. 30x squared times 40x squared. 30 times 40 is 1200. X squared times x squared is x to the power of 4. Now remember, when you have the same base and multiply, you have to add the powers. So x squared times x squared becomes x times x to the power of 2 plus 2, which becomes x to the power of 4. Next question. 3xy times 4xy. This is 3 times 4 equals 12. Xy times xy. We separate this to get x squared times y squared. And this all becomes, now x squared is similar to x times x, which is x squared. And the same is for y squared, which is y times y, which becomes y squared. Now 4x squared times 2xy. 4 times 2 is 8 times x squared times xy. X squared times x becomes x cubed because you have to add the exponents. Now we only have one y, so we multiply that. This will be our final solution. And this will become 8x cubed y. Next question. 3x times 4x squared times 5, x to the power is 6. Now, we follow the exact same steps we did before. First, we have to multiply the coefficients. Then we have to multiply all the variables. So, let's solve. We have 3 times 4 times 5. These are the coefficients. Then, x times x squared times x to the power of 6. These are the variables. So first, we multiply coefficients to get 60. Once again, these all have the same base, so we just need to add up their exponents. So here we have x to the power of 1 times x squared times x to the power of 6. We add up the exponents, and we get x to the power of 9. So we have 60 times x to the power of 9, which becomes 60 x to the power of 9. Next question. 5xy times negative 6xy. So here we have a negative number, negative 6, but we still follow the same rules. We have to multiply all the coefficients, so we get 5 times negative 6. This will become negative 30, because whenever we multiply two numbers, and if one number is negative, the product will be negative. So this is negative 30. Now the product of the variables is xy times xy. X times x is x squared. Y times y is y squared. So this is negative 30 x squared y squared. This is the product of coefficients. This is the product of variables. Next, we have to multiply two monomials again. We have 3x squared y times negative 3yx. So again, we have to multiply coefficients first, and then we have to multiply the variables. So 3 times negative 3 becomes negative 9. Then y squared y times y z. Now here we only have one x squared, and then we move on to the y's. Y times y becomes y squared, and we only have one z, so times z. Now we multiply all of this together to get -9, the product of coefficients, times x squared times y squared times z, product of variables. Next question. 3x times 4x times 3. First, we multiply all the coefficients, then the variables. So, 3 times 4 times 3, 36 times x, x squared. Answer is 36x squared. Here we have a next question. 4x squared times y times 3x squared y times 9y squared x. Multiply the coefficients to get 108, and then we multiply all the variables. So here we have x squared, and x. Those are all similar, so we multiply those together. They're all the same base, so you can add the exponents to get 2 plus 2 plus 1, and this becomes x to the power of 5. Remember, this has the exact same base, which is why we can add all the exponents to get x to the power of 5. Next, we multiply the 3 y's. So we have y to the power 1 times y to the power 1 times y to the power 2. They all have the same base, so we add the exponents, and we get y to the power of 4. And this will be our final solution. 108 times x to the power of 5 times y to the power of 4. Now here we have some application-based questions for multiplication of expression. First question is, here we have an image of a square garden, where each side is 4x, and we have to find out the area of the square. If the side is 4x, now what will be the area? It is side times side, or side square, or s plus s plus s plus s plus s. Now s is 4x. So area square is 4x to the power of 2. This is 4x times 4x, which equals to 4 times 4, coefficients, x times x, which are variables. So this is 16 times x squared. Area is 16x squared. Now, next question. Here we have a rectangular field whose length is 7y and width is 6y. Let's find the perimeter and area of the rectangular field. What is the formula for perimeter? It is 2 times length plus breadth. So we can plug in the values of length and width, so we get 2 times 7y plus 6y, which equals to 2 times 7y plus 2 times 6y. Now we solve to get 14y plus 12y. We add to get 26y. This will be the final solution. Or we can first add 7y and 6y to get 13y, then multiply by 2 to get 26y. The answer is the same either way. Now we can solve for area. What is the formula for area? It is length times breadth. Plug in the values for length times breadth, and we get 7y times 6y. Now we have to multiply coefficients and variables. So we will get 7 times 6 as 42, and times y squared. So area is 42y squared. Let's move on to the next question. Here we have a square board, and the side is -4p. What will be the area of this square board? Area of a figure is calculated with the formula side times side. Side is -4p, so we plug that in. -4p times -4p. First, we multiply the coefficient. So we have to multiply -4 times -4, then we multiply variables, p times p. So we multiply to get 16, because negative times negative is a positive, then p times p is p squared. answer will be 16p squared. This will be our final area. So next question. This is a rectangular board with a length of negative 12x and a width of 6x to the power of 3. What is area? Area is length times breadth. Plug in the values given and we have negative 12x times 6x cubed. So first we multiply coefficients, then variables, and we get negative 72 times x3. So how do we multiply the variables? Remember, they are of the same base, so you can just add the exponents. Therefore, we have x to the power of 1 plus 3. 1 plus 3 equals 4. So x times x to the power of 3 becomes x to the power of 4. Now we multiply these two together to get negative 72 x to the power of 4. This is the final area. Now let's have another question. This is also a rectangular board. It has a length of 5xy and 4xy. Let's find out the area. The area is length times breadth. We plug in the values to get 5xy times 4xy. Multiply coefficients, then variables. So we have 20, then times xy times xy. So here we can multiply x and x to get x squared, then y times y, which becomes y squared. So here we can just switch x and y to bring like terms together. Then x is at the same base, so we get x to the power of 2. Now we do the same thing for y. They are of the same base, so we can add the exponents. 1 plus 1 equals 2. So the final answer will be y squared. Now here we have 20x squared y squared. This is the final area. So kids, today we learned how to do multiplication for algebraic expressions.